change of the properties, delta U, delta H, delta S, and so on. So we're talking about the change of properties, delta H, delta S, delta A, delta G. And what we talk about, when we talk about this, it is U P2 P2 minus U P1 P2. And we know that for if the values are T and P, then du equals to, you can write as dou U by dou P at fixed T dt plus dou U by dou P at fixed T dt. And when we write it, it is actually what we look at. If you look at T and P, PT plane, then what we find that first we keep temperature constant and then pressure constant. Or whatever way, first phase will be this one, second phase will be this one. That is the way we actually go. If this is T1, P1, T1, and this is P2, P2, that's the way, so that this regime you can calculate the derivative, this regime you can calculate the derivative. This is valid for any materials, but if it is, we have shown that if it is ideal gas, then dou U by dou U Ig by dou P at fixed T equals to 0, right? And also we have found that dou U Ig dou V at fixed T equals to 0, and that says Uig, ideal gas, is U hat Ig of T is a function of temperature only. It is function of temperature only. Next, so that's what actually we did in the last class, and then I asked for the enthalpy, and now we have the enthalpy formula handy for you. So if you talk about enthalpy, we have dou H, dou Pt, we have dou H, dou Vt, we have dou H, dou Tv, because dou H, dou Tp, you know the Cp. So what are the expressions? You can volunteer dou H by dou P at fixed temperature. It is done actually already in the previous classes. Yeah. Who can actually volunteer? Because so many, yes, last page. V into 1 minus T beta. V into 1 minus T beta, right? Yeah, V into 1 minus T beta. V into 1 minus T beta. And for the ideal gas, how much it will be? So for ideal gas, dou H Ig by dou P T equals to 0. Dou H by dou V at T equals to T beta minus 1 by kappa. T beta minus 1 by kappa. And also you can see that for ideal gas, dou H Ig by dou V T equals to 0. Dou H by dou Tv is Cv by Cv. Dou H by dou T at fixed B is pardon? Cv plus V beta by kappa. Cv plus V beta by kappa, and which is coming for dou H Ig by dou Tv equals to Cp. It is coming Cv plus R. Check it out. This is coming Cv plus R, Cp. Correct? Cp. So U and H, they behave same manner. Uig is Uig at T, Hig is Hig at T. So U and H behave in the same manner. Hig equals to Hig at T. Next we will take S, entropy. For the entropy, if you can write dou S by dou T dt plus dou S by dou Pt dP if it is S equals to S at Tp. We can also have S equals to S at Tb. Then we can write ds equals to dou S dou T v dt plus dou S dou Vt dV. Okay. So now we'll be interested on the ideal gas, but first we write the expression for dou S by dou Tp, which is Cp by T. Am I correct? Dou S by dou Tb, which is Cv by T, dou S by dou Pt minus beta B, which is coming for ideal gas, dou S Ig by dou P T equals to 0 or minus in terms of P minus R by P. Yes or no? We should not write in terms of V, because you can see that's a function of temperature and pressure. So if you write in terms of pressure, V should not come in picture. That's the when you give the expression, as I told you a long time, that see the function, this function of temperature and pressure, the final expression in terms of temperature and pressure. So what's the temperature and pressure function? Pardon? Minus R by P, that's what I said. Minus R by P. And then dou S by dou Vt equals to, that is actually coming from your Maxwell's expression sheet, dou P by dou Tb. Am I correct? Yes or no? Okay, so dou S Ig by dou Vt, it is coming as, what is that? One hand please, only one hand. Yes. Beta by T. Is it correct? Beta, why beta will come? It is an ideal gas, no? T by P. Just I have so many answers, I am really getting confused. So many answers. Who can give the correct answer? Please don't buzz, because I get confused. You know, and class things should get hampered. If anybody is willing to answer, please raise them, because I am not. Yes. Beta by gamma. It is R. I am talking about Ig. Ig means PV equals to RT. R by V. R by V. Please try to understand this actually. Ig means PV equals to RT, and you have to express in terms of V and T. So many times I am talking. There is nothing much to remember. You have to just have the concept. If you have the concept, you can get the answer. Okay. So now this actual situation is different here for SIG, and it says that SIG is definitely a function of temperature and pressure, the Tp plane temperature and volume. It is not like these functions, because these guys are not becoming zero. This is non-zero, this is non-zero. In fact, at speed tending to zero, this guy will have the large number, so it contributes quite a lot. Of course, the function of constant temperature, function of volume, but it is not a constant. It has got some value. So we can write SIG is S hat Ig Tp, or SIG equals to SIG Tb. It is not like H and U. Similarly for A, if you want to talk about A you know what will happen. A equals to U minus Ts, that is there. G equals to H minus Ts, although it is a function of temperature, but this function of temperature pressure, it is function of temperature pressure. So AIG, SI and GIG, they will be the function of temperature and pressure, or function of temperature and volume. Funda is clear. Okay. So what we what we are saying that if you want to talk about what will be the expression for the if I offer the ideal gas leading, if I want to have delta Sig, what is your expression? What is your delta Sig T2 P2 minus Sig T1 P1? What will be the values? What will be the values? In TP plane, yes. Sig T2 P2 minus, because for this expression basically find out Sig. What is that? The two terms will be there. One for dou S by dou T at fixed speed dt. We can get very cute expression. Two terms. What will be the terms? What will be the terms? Remember that CPIG, this kind of expression will be there. Many of the books. The function of strong function of temperature, Cv also. But with no Cp and Cv, Ig as a function of temperature. Any other materials we don't have the values, we don't have the expression. So CPIG, CVIG can be determined. Cp and Cv cannot be determined so easily. Yes, so what's our expression for Sig T2 P2 minus Sig T1 P2? Any idea? There are two terms. I just want to know the answer. You don't know how to do it? You don't know how to do it? Why? I'm really shocked to see you. I'm just shocked to see you, that's it. Maybe I'm a failure in teaching thermodynamics. Please look at the board. Please. When I'm talking to somebody, if you just keep quiet, because as a teacher, I have to pay attention. I think you are not getting disturbed by my attitude. I'm sorry for that if you are getting disturbed. Because sometimes you may put some poster. That is always there. So if you feel that I shouldn't ask you, then I can go ahead, right? Is that okay? Or you can get help from your friends. Yeah, that's fine. Yeah, any answer?
Cp ln T2 by T1 minus R.
No, it is not correct. It is not correct. So how to do it? We know that when you say S equals to Sig equals to Sig hat Tp dsig ds at Ig Tp, and this is dou Sig dou T P dt plus dou Sig dou Pe dt. You understand this step? Then how to calculate this one? You know the limit ds. So this is like a delta S Ig, which is nothing but T1 P1 to T2 P2, and that's it. Integral T1. Here it is. Here P is fixed at what pressure? Here P is fixed at what pressure? P1. Or you can, if you want to take this a first step, this is better. The second step, so temperature is fixed as T1, right? In that step. So it is T1 P1 to T1 P2 dou Sig dou P T dt plus pressure is fixed as P2. That means this will be at P2, right? So P2, temperature was fixed of T1 here, right? So what I was doing, just your diagram is there with you. This is your diagram. This is T axis, this is P axis. So I am starting from here. Here the temperature is T1. Here the temperature is T2. So my point is P1, T1, P2 T1. Then at this level pressure is fixed and I am going P2 T2. So P2 T1 to P2 T2. Is it clear, sir? I don't know. You are saying yes, I am accepting. Dou S Ig dou T P2 dt. Am I correct? Yes. As I said, Cp is a function, Ig is a function of temperature, which is A0 plus A1T plus A2T square plus T2, whatever temperature function. So, and this is what is this expression? Dou S Ig by dou Pt. This is different. This is minus R by P, right? So this is T1 P1, T1 P2 minus R by P, right? Minus R by P dP plus this is P2 T1 plus P2 T2. Cp Ig is a function of temperature by T dt. So you should be keeping like that. You are what he was saying that you are keeping Cp constant. Cp Ig, this is very rare case. It's a function of temperature. Function of temperature, this entire integral should be evaluated together. So S Ig P2 P2 minus S Ig P1 P1, which is R ln P2 by P1 minus T1 P2 comma T1 P2 comma T2 Cp Ig T dt. So this is the way. If you are an ideal gas regime, you can calculate. But this will not work for the real gas, because for real this is not the right expression, and for real it won't be Cpig, it will be Cp, and Cp we don't know. So this will be some complicated expression you can evaluate, no matter. But this we don't know Cp, we know only Cpig. So if you want to do delta S for Tp plane by this like this, it will be completely unknown. So, but we have to calculate delta S, and it is not always the pressure is the tending to zero digit. Pressure will be somewhere having some finite value. Pressure will be having some finite value. Material is real. Material is not ideal. If it is ideal, it's okay. If it is real, this method will not work. So we will be introducing the concept of thermodynamic departure function. We will be introducing the concept of thermodynamic departure functions. So remember that you need to calculate delta U, delta H, delta S, delta A, delta G. We have to we can calculate from T to P to T1 P1 or T to V to T1 V1. Okay, this is very much idealistic, just because anyways as a chemical engineer is a duty to calculate the change in property, thermodynamic property. That's what we will be always interested. But it is so simple to think about. We are calculating only the change in property U T2 P2 minus U T1 P1. But the process of the calculation is not that simple. So we have to introduce the concept of thermodynamic departure functions. Thermodynamic departure functions. Okay. What I am saying that for this expression, if you talk about where we have the delta S, where you have the delta S Ig, which is very simple to expression, everything is known. But if you have any property which is not an ideal gas property, the real gas property, the real domain, these things will be unknown. That means what will be having, for example, we have a property called M, dm, which is rho m by rho p t dp plus rho m by rho t p dt. And if you want to calculate m t2 p2 minus m t1 p1, we will get something, some integral term that we can actually get from the equation of state. And if m is s, you have Cp dt by t. It is not known. So this method will fail. This two-step method will fail. Two-step method will fail for real system. Two-step method will fail for real system. This two-step method will fail. Going like this, going up, it will fail because we don't know Cp. We know only CPIG. CPIG is available. Go to British Chemical Engineering Handbook, YBC Rao, standard, CPIG for all materials will be available. But once you go to real system, this two-step process will be failed. But it is possible to have CPIG. Use the CPIG and proceed further. So what will be the proposed way to calculate change in property by using CPIG? Any idea? Let me put the question. For ideal system, CPIG is coming, but you don't have ideal system, and CPIG is basically for the pressure is basically the very low value. The pressure is very low value, then only you can get CPIG. And we are assuming that the entire system pressure P1 and P2 both are tending to 0. For ideal system here, if we say is both P1 tending to 0 and P2 tending to 0, and you can happily apply all this. But for our case, they are not tending to 0. The real system, what chemical engineers will be interested on. But if you go by the two-step method, as I said, it will fail because Cp we don't know. We know only CPIG. So what will be the possible path? This path will not work. If you go by this path, and remember that this thermodynamic properties, they are path independent function. That means what? Instead of going like this, we can go like this. Same value we get. No problem. It's path independent function. We have discussed on that. So what path we devise so that we can actually get CPIG? Yes. No idea.
So we can construct, we can introduce some parameter.
Parameter you won't introduce. No, don't need to introduce any extra thing.
From this ideal gas, we can subtract a particular value from which.
How you that is no idea. You just go by the actual physics. Is very superficial. We know only the path. To calculate, you know that you can reach from P1 by this, or you can go by this. Why I have to go by this? Because you can find out derivative like this at constant temperature or pressure. If you go straight, difficult, impossible. Always you have to go by horizontal or vertical path because these kind of derivatives are available. This kind of derivatives are available in the market. You can take from market and use it free. You don't have to buy. You go straight also, you can go straight. You can go like this. You can go like this. Anyways, everything will same. If you get all the values, no problem. You won't get the values. You are only permitted to go by the horizontal. This is a good puzzle. Horizontal, vertical path. How to do? Yeah, I just wait. I just want to see from others who can suggest anything. Is it possible to go by the P tending to 0 so that at least you can actually get CPIG? Is it possible to have? Because Cp, when I say this Cp means what? Pressure is constant. Pressure is constant. Rho H by rho T at fixed P is Cp. Right? Pressure is constant. That means if I have the constant pressure tending to 0, that means you can still use CPIG. Right? Am I correct? This pressure P2. If I say my P2 is tending to 0, that means you are going via the low pressure regime. Then at least you can use CPIG. What will be your path then? I have given enough hints. What will be your path? From here to here. What will be your path?
Constant P1 constant P2.
Constant P1, constant P2. Huh? Constant P1 is there. P1 to P2.
Constant P1 and constant P2.
Constant P1 path. How will you do that? It will be how many steps? 2 steps again? No, your things don't make sense. If I say constant P1 path and constant P2 path, then where shall I end up?
I can have my P1 as P1 tends to 0.
No, P1 cannot be tending to 0. P1 cannot be tending to 0. P1 is very large value. P2 is large. I cannot change this P1 P2, otherwise my problem is solved. Otherwise my problem is solved. This is my point, this is my point, this point is P1, P1, this point is P2, P2. This, from here I have to come here. From here I have to come here to calculate the change in property, very simple. As a chemical engineer, you have to calculate change in property.
So we can go by step.
How to have the step?
With the midpoint we can go
Midpoint, but how to calculate? I said that my problem is to calculate the dou H by dou T at fixed P. That dt, integral, if I am talking about enthalpy, it is what? It is Cp dt, right? The Cp dt, very simple. If I let's talk about enthalpy.
So how about defining a new axis?
Pardon?
Defining a new axis.
New axis, don't complicate. Try to have the physical solution. If you put jargon, you can tell jargon. I can also tell jargon and leave the class if I don't give any solution.
Usually path from P1 T1 to 0 T1, then to P1 P2 T1, and then
Excellent. Very good answer. You do earlier learned this or this is the first time? First time. Excellent, madam. Congratulations. So what madam is saying, this is the point where P1 tending to 0. They are P tending to 0, not P. P tending to 0. This is the P. Then go straight. Come here. So it's a 3-step process. You have to put a halt at P tending to 0. This part is what? This part is dou H by dou T at P tending to 0. That means you have the problem with the vertical path. So vertical path I am doing by P tending to 0. Horizontal part is okay. Horizontal path you have the formula, you put the formula, you get the answer. We have the problem with the vertical path. Vertical path, instead of going here and there, I will go by P tending to 0. My problem is solved.
But
Yes.
if you do that, you will get ln of 0. So
Ln of 0. Okay, let's see. Let's see. Let's see. Let's see that part. You are saying that ln of 0. This is, you are talking from here. You are doing a mistake. My calculation is not the ideal gas property. I am doing real gas, so this will not come. Okay? But we will see what we will get. I do a lot of problems with that. It's just a starting. So you understood the part. Let's proceed. I'll take enthalpy. Calculation of enthalpy for the first step. Let's say calculation of enthalpy change, delta H. So now delta H will be equals to, in terms of integration, the steps, who will give the step? What was the step here? If I do like this, delta H, what will be the step? For two-step process, delta H will be, who will volunteer? Any hands please? Any hands? Yes. Integral first you have to do this. So P1 P2 P1 dou H by dou P T1 dP plus P2 T1 P2 T2 dou H by dou T P2 dt. Very simple. I am not doing anything complicated here. Delta H for three-step process. What will be? What will be for three-step process? Who will give? There will be three terms, right? Each step, each integral. Each step, each integral. So there will be three terms. No. Somebody else. Somebody else can do that. Yes, madam. Can you do that? Integral P1. I am not just saying T1 and T2 because that you can actually know that which will be integral. Limit. Then T1, don't forget it because that I was doing initially. P tending to 0. Dou H by dou P T1 dP. That's why I'm not writing because since I'm saying T1, there's no point to write T1 here because the limit this actually says that because that is mathematically incorrect. I should not write the limit T1 because I'm doing only for dP. What I was doing just to make sure you are understanding. Now you don't write proper mathematical form. Next step. T1 to T2.
Dou H by dou P at constant P tends to 0.
Dou H
By dou T
dou T
at constant P tends to 0.
constant P tending to 0 dt plus
integral P tends to 0 to P2
P2
dou H by dou P at constant
dou H by dou P constant T
T2
quite clear to all of you. These expressions I will express in a generalized format called departure function. These two I will express in terms of departure function. Okay. So if I say any thermodynamic quantity M minus Mig, I am now defining a new function called departure function. This is called departure function. This is called departure function. You have to calculate this M minus Mig, TIP. And generally, departure function we talk about, it is an isothermal path. Horizontal route, horizontal path. So departure function is basically for the path where temperature is constant. In order to do that, this is departure means how far your property from ideal gas. How far your property is from ideal gas at a temperature TIPI. But yes.
Sir, why you are not considering the
middle term actually I'll evaluate. I cannot evaluate by departure because it is known. It is CPIG dt. It can be evaluated. Already you have done it. It is having no problem now. This part is solved. Yeah. This P tending to 0 means CPIG. This P tending to 0 means CPIG I can write. Otherwise you cannot write. Okay. Because we know that dou H by dou T P, this Cp, but it is P tending to 0, it will be Cpij dPa. Okay. So this is departure function says that how far it is departed from ideal gas property. How far it is departed from ideal gas property along the horizontal line. Because if you look at the horizontal line, your ideal property is here, sitting here. So, with respect to this, how far it is, that's called departure function. Let's look at how to coordinate this with this integral. You can appreciate better. So, since we are talking about horizontal path, so horizontal path means temperature is constant, right? Horizontal path is temperature is constant. It is nothing but rho m by rho p t dp. Right? Temperature is constant is equation number A. If you integrate, which is Ti, temperature is constant, I am just doing for you, P equals to 0 to Pi, which is Ti, P tending to 0 to P. Initially my substance, the ideal gas state, I am saying how much, this dm, I can put any integral, I can also put Pi here, P tending to 0 here, but I am actually assuming that my initial situation is ideal gas, I am going to some point of Pi. Okay, I am going to some point of Pi. And since my path is isothermal, constant temperature path, I can write this T inside. Okay, so this will be m Ti Pi minus m Ti P tending to 0, right? Integral Ti P tending to 0 Pi dou m by dou P Ti dP, equation number B. Similarly, we can write dmIg equals to dou mIg dou P Ti dP. So what should I write? MIG Ti Pi minus MIG, just like same kind of only M will be replaced by MIG, right? Same expression, MIG Ti P tending to 0 integral, who will be corrected here? Let's see what you are understanding or not. Who will be the right hand, what will be the right hand side? Ti comma P tending to 0, then Pi dou MIG by dou P. So simple. I am really surprised the entire class is just keeping quiet. Entire class is just keeping quiet because I don't know why. Equation B and equations B1, they are very similar. Only M is replaced by MIG. And any substance will behave like Ig at P tending to 0. Any substance will behave like Ig if P tending to 0. That means M Ti P tending to 0 can be written as MIG Ti P tending to 0. Am I correct? Any substance would behave like ideal gas as P tending to 0. The property at P tending to 0 is nothing but ideal gas property at P tending to 0. Right? Yes? Okay. So if you subtract equation B1 from B, if you subtract equation B1 from B, what will you get? If you subtract equation B1 from B, what will you get? If you subtract equation B1 from B, what will you get? What did you get? You subtract equation.
Difference between ideal gas and real gas.
No, please don't talk in stories, please. You tell me the expression. Left hand side. It's so simple.
MTIPI minus
MTIPI minus, because I am subtracting B1 from B. Please try to understand my English. Maybe my English is bad, I don't know. Minus MIG equals to, right hand side, how many terms will be there? Right hand side, how many terms will be there? 3 terms, 4 terms, 5 terms. Right hand side, how many terms will be there? I am seeing your strength of mathematics is so good. How many terms will be there? 2 integral terms. You are just doing research on that. How many terms will be there? It should come in few seconds. How many terms? What are the terms? Integral is there, man. You are just neglecting. It is not like a child's play. It is not like child's play. If I just say some term and I push up, you will throw mud on me. Because what kind of teacher it is. I won't do that. I try my best. I don't know how much is penetrating to you. That is your part. But I am trying my best. So integral pi p tending to 0 to pi, not pi tending to 0, p tending to 0, which is dou f by dou p dou t dou p ti dp plus minus, yes, pi p tending to 0 pi dou f by dou f ig by dou p ti dp. Am I correct? So this is your departure. So your departure function is m minus mig ti pi is nothing but ti p tending to 0 to pi dou m by dou p ti dp minus ti p tending to 0 pi dou m ig ti dp. For enthalpy and internal energy, this term will be 0. Yes, madam. You have to be prompt. You have to feel the thermodynamics. If you start mugging, then that's it. You won't feel it. But for entropy, this term will not be. For enthalpy, so for this case, I can write this term as now you can see, by integral you can easily tell the terms. For enthalpy, what can I write? This term for the first term. Everything is there in the board. Yes, madam, yes. Not departure, you have to write in terms of actual expression. If you say departure function leave, I am not doing exactly what mathematicians want. I have to write in terms of mathematical function. What is the departure function? What is the expression for departure function? You don't know. It is their departure function, madam.
X minus HI.
Yes. It will be departure function. Departure function is defined as p tending to 0 pi minus p1 to p tending to 0. So what should I write? Minus of h minus hij temperature T1, P1 plus integral T1 to T2 dou h by dou t p tending to 0 t dt plus h minus hij T2 P2. This is your delta H. Clear? So enthalpy change is nothing but negative departure function at temperature T1 P1 plus this integral which is Cpig dt plus departure function at T2 P2. If you have generalized departure function, you can actually evaluate departure function in a computer program and you just substitute T1 P1, you will get this expression, you can get this expression. You have already this and you can calculate delta H. So I will proceed next to calculate. So what we have learned, H minus Hij